All right, good morning. So today we're going to be talking about dividing fractions. So the first thing that we're going to discuss is what is division, right? So there are two different types of division problems, okay? And we're going to look at it using whole numbers first, and then we're going to look at division with fractions. So if we think about just division with whole numbers, we can think about partitive division. You don't need to know partitive, but you need to know the type of question or the type of division, okay? So let's look at this one here. Let's say that we have 48, okay? I have 48 cookies, and I have 4 friends, okay? And I want to figure out how many cookies each friend gets. So this type of division is I have a total, I have a group, and I need to figure out the size of each group or how much I'm sharing. So think about this as the sharing division, right? Which is why it's called partitive division. We've talked about partitioning a lot, right? We use that word a lot in math, and we've been using a lot with fractions and decimals, right? So this is that sharing type of division where we're figuring out how much we can share to each friend. Another quick way to think about it is total divided by a group gives me my each. So we know the number of complete and equal groups, we know the total amount, and we're figuring out the size of each of what's going to go into each share. And we can see that in here in our picture, we see 48, and we see that each friend is going to share 12 cookies. The other type of division is called the measurement division. This is where we know the size, we know the each, and we have to figure out the group. So for example, if I have 48 cookies, and I know I only want to give 4 cookies. So my friends request, hey, if you have 48 cookies, I'd like to order 4. Well, how many friends can you sell your cookies to? And so then you're figuring the number of groups. So this is called measurement division, where you actually are given the size of each group, you know your total, and you're figuring out the number of groups. So we see that over here. Okay, a really quick way of thinking about it is I have a total, I have a group, and I have the total, I have the each, and I have to find the group. So let's go back to division with fractions, right? It's the same two types of division, but we're representing now with whole numbers and fractions. Okay? All right, so we're going to go over here. Let's look at this problem, and let's look at the type of division problem it is. So the word problem says the board is 4 feet long. Oh, that's my total. If the shelf is 4/6 of a foot long, oh, this is the size of each one. So I'm dealing with a division problem where I have a total, I have the each, and I'm trying to figure out the number of groups. I could write that expression as 4 divided by 4/6. In other words, this means how many of the second number, the 4/6, can I get out of 4 holes? How many 4/6 are in 4 holes? So here I have 1 hole represented by my 4 feet long board. And I want to cut this into 4/6. That's my each. That's the size of each group. Okay. And each shelf is going to represent 1 group. So I have my number line on here. And notice on here, let's look at that number line really closely. Let's see how that number line is partitioned. How is it split equally? So if we look on here, I have 1, 2, 3, 4, 5, 6. Each hole is partitioned into 6 intervals or 6 tick marks equally. I'm going to go ahead and skip count 4/6. So you can think about this type of division as almost like repeated addition. You're counting to see how many 4/6 you have. So I'm going to count here. 1, 2, 3, 4. Okay, that represents one shelf. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Make sure I got it right. Okay, so I can only make 1, 2, 3, 4, 5, 6 whole shelves. And when we talked on our last Zoom session about, hey, we know that if we start with a whole, we're going to end with a whole. Well, that makes sense because I'm dealing with whole shelves. So I'm going to they're asking how many shelves can you make? Well, I can technically only make 6 shelves, right? If I'm making a bookcase, here's my bookcase. It makes sense to have my 6 shelves. 1, 2, 3, 4, 5, and 6. Now we notice on here that we have these 2 6 left over. Okay, so here's my 2 6 that's left over. Can I make a shelf out of it? No, right? Because the size of a shelf is going to be 4 6. So it doesn't make sense for me to write in my answer that I'm going to have the 2 6. Right? I can't make it because obviously everything's going to fall and nobody has a shelf that can just stand no shelf can be 2 6 and just stand by itself. It doesn't make any sense. So I'm going to write my answer is 6 and 2 6. But when I'm reading my question and what it's asking for me, my final answer is I'm only going to have 6 shelves. Okay, so my final answer is 6 and 2 6. But if I'm looking at that word problem, they're asking for how many whole shelves. My answer is going to be 6 holes. I can't have 2 6 of a shelf. I'm going to have things that are going to fall off the shelf. Okay, here's another example. The board is 3 feet long. Oh, my total is a hole. If a shelf is 2/4, of a foot long, that's the size of each group. They're asking for how many shelves. This is again going back to that partitive division. We're doing a total divided by our each to figure out how many groups. So it's literally just repeated addition. How many 2/4 shelves can I get out of 3 feet long shelf, right? So how many 2/4 are in 3 feet? So I'm going to look at my number line here, and I'm going to look at how is my number line partitioned? How is it split equally? If I look at each hole, I notice that I have 1, 2, 3 tick marks. That means that this has 4 spaces in between. I have 1/4, 2/4, 3/4. And I could continue doing this on my number line. My number line is always going to have the same amount of tick marks for each one. So this means that this is 1/4, 2/4, 3/4, 4/4 makes a whole. So this would be 8/4, and I could keep going. So I want to figure out how many 2/4 are in 3 feet. So how many of the second number is in my first number? I'm going to write my expression is 3 divided by 2/4, and I'm going to figure out the number of shelves, which means I'm going to have a whole number. I'm still going to write my remainder, what's left over, but when I do my final answer, I'm going to say 6 shelves. All right, so I'm going to skip count every 2/4. 1, 2, 3, 4, 5, 6. Oh, I can make 6 shelves again. Worked out. And I'm going to write 6. Check it out. My answer works perfectly. Okay, so this one didn't have any leftover. So good. We didn't have to think about it. Same thing as for here. You can go ahead and on your Google Classroom, I want you to check out and try to do this one. The board is 4 feet long. If a shelf is 2/6 of a foot long, how many shelves can you make, right? So first we're going to think about what type of division problem we have. We have a total divided by a each. We're figuring out the number of groups. We're kind of doing pretty much repeated subtraction, right? Or we're skip counting, right? We're doing the opposite of multiplication. How many shelves can you make? And then you're going to tell me in your answer, write down the expression, tell me what would be the division problem, and then what would be the answer. All right, so that is dividing a whole number by a fraction. So we're looking at partitive division, right? We're finding the groups. All right. Is there anything else I'm going to show you? Let me see if I can show you in a different way the different types that you can see. So I'm going to give you one more. So we looked at the number line. Now we're going to look at the area model, or just using pictorial models. So here's a question. Isabella has 3 pounds of cherries. If she makes 3/4 of a pound of cherries to make 1 cherry pie, how many cherry pies can Isabella make? So I'm going to be really important to see if which one's my total, which one's my group, and which one's my each. And I think it's very important to just write down TGE so that you can kind of pick it apart. Well, if she has 3 pounds, she's starting off with 3 pounds. So that means my total is 3. If it takes 3/4 of a pound of cherries to make 1 cherry pie, this sounds like this is a each. How many cherry pies can Isabella make? Okay, so the cherry pies let me fix this here. This is my 3/4. This is my each. I'm trying to figure out how many groups. So for the G, I'm going to actually write a question mark. Now I'm going to write down my expression. My expression is 3 divided by 3/4 equals a question mark. What is my quotient? Which is the number of groups. Notice that on here in your word problem, this is what's given to you. That's what you're going to write. This is what you have to find. Now we're going to go ahead and we're going to get started creating the pictorial model for this. I know I have 3 holes, so I'm going to take out my 3 holes. Okay, I'm trying to figure out how many 3/4 are in 3 holes. I'm going to look at that denominator. That denominator says I'm going to partition into fourths. So I'm going to take my fourths, create my, there we go. I'm going to do that for all of my holes. Okay, now I'm going to count the number of groups, okay, where the size is 3/4. 1, whoops. Oh, is it going to let me? Is it going to? There we go. Let's see if here's another 3/4. Here's another 3/4. I was able to make 3 whole pies, and I'm going to have another pie here. So guess what? I get to make 4 cherry pies because I made 4 groups of 3/4. It's not going to let me write. I'm going to do my best, but it's not going to let me write. So 3/4, 3/4, 3/4, and 3/4. So that means I'm going to have 4 cherry pies. Okay. Same thing here. Here I have 4 pounds of cherries. This time, the size of each group, or the size of each, is going to be 2/3. And I'm trying to figure out the number of pies, so I'm going to figure out the number of groups. If I start with the whole, that means, yes, if I'm looking for whole groups, I should have a whole number, right? I may have some leftovers, but it's going to be really important that I look at that question to see if I need to have the leftovers, right? But since I only want to be making whole pies, I want to only enter in a whole number. Okay, so that's how you do a number line and area model for partitive division. All right, so if you have any questions on that, please let me know. All right, thanks, guys.